For problem number 2, it says a pumpkin is launched from a man-made catapult from 7 feet up in the air. The pumpkin has a velocity of 512 feet per second. Taking into account the effects of gravity, write the function that would represent the height of the pumpkin off the ground. So for this, we know that if gravity is affected, we know that that means that we need to use negative 16 t squared somewhere. Because remember, that's the expression that represents gravity's pull on the earth. Then we're going to use the 7 feet and the 512. The 7 feet is where it initially starts, and the 512 is another name for that. Well, they said is velocity right here. So for velocity, that's when we're going to do 512 t, because that's always the velocity that's per second. So that's why it's the t needs to be there. And then it's starting at 7 feet up in the air. So the 7 feet is the initial starting point, which would be the y-intercept. So this would be the equation that we would write, the function we would write to talk about this. So f of t, because they said function. So this would be the function of it. Now for part B, it says using technology, estimate when the pumpkin will hit the ground. So we need to take this function and put it into Desmos. So let's go there. We're going to go into Desmos and we're going to write the formula, and it was f of t equals negative 16t squared plus 512t plus 7. So that was the equation that we just wrote. And now the question said to find where it hits the ground, but right now we can't see anything. So they did give you a hint of where to change the scale. So the x min is -10, the x max is 40, and then the y min is -5, and the x max is 8,000. So we're going to change those numbers, and we change them on Desmos by hitting that little wrench. So we're going to hit that wrench, and it said the min was -10 and the max was 40 for the x-axis. So we're going to change this to 40. And then the y-axis, they said to make it -5 to 8,000. We're going to make it -5,000. And then we can hit the wrench so we can see. Oh, I forgot to make it 8,000. I made it 800. My bad. There we go. All right, so now we can see the graph. I'm going to raise it up a little bit. And so now it's asking the question that we're supposed to answer is when will it hit the ground? So remember, this is the motion of the pumpkin. So this is where it takes off. This is where it peaks, and then this is where it comes back and hits the ground. So I can click here, and it looks like about 32 seconds, and that's close enough to write. So when we go back to here, we're going to say 32 seconds. 32 seconds, and we can put the little about. All right, and make sure that you see that we included the seconds, the unit on our answer. So we should always include it whenever we're talking about word problems. Then part C, it says, what is the maximum height of the pumpkin? So going back to our graph, we're looking for the vertex. Remember, that's where it changes directions. And for this case, it's the maximum. So we can click on there, 16 and comma 4,103. So the 16 represents the time it takes to get to the maximum, and that 4,103 talks about the feet, how high it is up in the air. And so it specifically says to answer what is the maximum height of the pumpkin. So that's at 4,100 and double check and 103. So it's about 4,103. And remember, it was feet that they're talking about. That was the velocity that they mentioned up here, that it's feet per second. And then part D said, what would the reasonable domain be for this function? So going back to the graph, we're looking for the part that makes sense. So even though this graph goes below 0, it doesn't make sense that the pumpkin would be going through the earth to get to the catapult. So we're going to start at 0. And then once it hits the ground, again, it's not going to continue to go through the earth after it hits the ground. It might go through the ground a little bit, but really the pumpkin's probably going to break. So the reasonable domain is between 0 and 32. And there's a couple ways that you can write it. You could do 0 is less than or equal to X, which is less than or equal to 32. That would include the domain because we're talking about the reasonable X values. And this is the part of the graph that we would want to look at. So we would write it like this, because that's the part of the graph that actually makes sense when it comes to the pumpkin. So from this spot over, from here, and this spot is the only part that actually makes sense when we're talking about the pumpkin. The rest of this is making it look like the pumpkin is actually going through the earth, which doesn't make any sense.